Lesson 2.1, solving absolute value equations and inequalities. Its best standards are MA 912, AR 4.2, and AR 4.4. So absolute values, it's a number that is the distance from the zero on the number line. Normally we would solve equations by isolate the absolute value expression on one side of the equation, write our two cases, use properties of equality to solve each case, and then check our solutions. But for this lesson, we're actually starting with inequalities. So solving absolute value inequalities algebraically. So when we're solving absolute value inequalities, there are two cases to consider. They can be written as case 1 and case 2. The first one is known for the and statement. So there's two solutions between it. And the second one is the or statement, which means it's going one against the other. And these are our setups of what we would use. So in order to apply this, we're going to actually tackle some problems. So in example 5, it says solve an absolute value inequality. And for this one, it's going to be the or process, where it's less than or less than equal to. So in our problem, it says solve the absolute value of 4x minus 8 minus 5 less than 11, then graph the solution set. So first thing we need to do is isolate our number. So in order to isolate our number, we're going to add 5 to both sides, and I become a 16. So then I have two scenarios here. Because the inequality uses the less than, we're going to rewrite it as a compound inequality. Since it's using the less than symbol, it's going to be a compound inequality, which means it's joined by the word and. So we have, in order to do this, we're going to have an opposite value situation. So the first one says 4x minus 8 less than 16 and 4x minus 8 greater than negative 16. So in order here, we flipped the inequality and then changed the sign. So again, we're going to flip the inequality and change the sign. So now I'm going to add 8 to both sides. So I get 24. I'm going to add 8 to both sides, and I get negative 8. I'm going to divide by 4 to both of them because, again, you have a 4 attached to x. So I become a positive 6 and a negative 2. So x is going to be less than 6 or greater than negative 2. So our solution set is, so now it's going to be the most negative number first. So you're going to write negative 2 less than x less than 6. Remember, we're always going to go from left to right, which means negative to positive. The solution set symbols represent the interval between two numbers. So because we have less than symbols, we're between negative 2 and 6, but they are not solutions. So in order to do this, we're going to use circles, but we're going to actually use open circles. Which means they're not inclusive. So I'm going to have an open circle at negative 2, an open circle at 6, and then any number in between the two would be a solution. In example 6, in absolute value inequality, this is now our or statement, one or the other. So it says solve the absolute value of 6x plus 3 over 2 plus 5 greater than or equal to 14, then graph the solution set. So you start out with your original equation. First thing we need to do is isolate our absolute. So I'm subtracting 5 over. So I become a 9. And then I need to get rid of this denominator here, which is a 2. So I'm going to multiply by 2, and I become 18. So now we have absolute value of 6x plus 3 greater than or equal to 18. Because the inequality has a greater than symbol, we're going to write it as a compound again. But this is going to be the or statement. So we're going to, again, flip the inequality and change the sign. So we have 6x plus 3 greater than or equal to positive 18. And now 6x plus 3 less than or equal to negative 18. Again, we're going to isolate our numbers. So I'm going to subtract 3 to both sides, and I get a 15. Subtract 3 to both sides, I get a negative 21. And then we divide both sides by 6. So now we get 15 over 6. But remember, 15 over 6 is reducible. So it reduces to 5 over 2 because they're divisible by 3. Here we have negative 21 over 6. And again, divide by 3. And I get negative 7 over 2. So we divided by 3. So x has to be greater than or equal to 5 halves, or x is less than or equal to negative 7 halves. So when we write our solution set, it's going to be x if and only if x is less than or equal to negative 7 halves, or, because remember we were an or statement, 5 halves. When we have our pieces, all values of x less than or equal to negative 7 halves, as well as all values greater than or equal to 5 halves, satisfy the constraints of the original inequality. So our solution set represents the union of two intervals. Because greater than or equal to and less than or equal to indicates that they are part of the solutions, the graph of the endpoints are going to be using dots. So we're going to have closed statements. So again, it said that all the values of x are going to be less than negative 7 halves. Well, negative 7 halves is about 3.5. So I'm going to have a closed dot at 3.5, but I'm going to the left. And then at 5 halves, which is the same thing as 2.5, in between 2 and 3, but I'm going to the right. Notice that our graphs are not overlapping. They are not overlapping, which means in this section here, these are no solution values in between them. Okay, in example 7, our word problem says write and solve an absolute value inequality. This one's based on sleep. So it's saying you can find how much sleep you need by going to sleep without turning on an alarm. Once your sleep pattern has stabilized, record the amount of time you spend sleeping each night. The amount of time you sleep, so the amount of time you sleep plus or minus 15 minutes is your sleep need. So it says, suppose you need sleep 8.5 hours per night. They want us to solve an inequality to represent our sleep need, the graph solution on the number line. Okay, so it says part A, write an absolute value inequality. This says the difference between your actual sleep and need the amount of time is less than or equal to, well, again, it's less than or equal to 15 minutes, as stated here, plus or minus 15. So 8.5 hours is going to be our central value, and 15 minutes, which is the same thing as saying a quarter of an hour, 0.25, I'm going to go with decimal point, is acceptable range. So the difference between our actual sleep need and 8.5 hours is going to be 0.25 hours. So we're going to let n represent our actual need, so it's n minus 8.5 hours less than or equal to our 0.25. On part B, solve the inequality and graph the solution set. So again, we're going to rewrite our absolute value of n minus 8.5 less than or equal to 0.25 as a compound inequality. Again, remember, you have to flip the inequality and then change the sign. So we see n minus 8.5 less than or equal to 0.25, and then n minus 8.5 greater than or equal to negative 0.25. So we are going to add 8.5 to both sides. and we get n is less than or equal to 8.75, and then n greater than or equal to 8.25. The solution set represents the interval between two numbers because the less than equal to and greater than equal symbols indicate that 8.25 and 8.75 are solutions. We're going to graph the endpoints on the number line using dots, so solid dots. So, and then we're going to shade the interval from 8.25 to 8.75. So on our number line, we have a solid circle at 8.25, a solid circle at 8.75, and in between, which means any number in between these two are inclusive. So any time frame in between 8.25 hours to 8.75 hours is a solution to our problem. In our check problem, it says food or service. Survey found that 58% of Americans adults eat at a restaurant at least once a week. The margin of error was 3%, or margin of error was 3 percentage points. So again, 58% of Americans eat at a restaurant. So for part A, it says write an absolute value inequality to represent the range of the percent of Americans who eat at a restaurant during the week, where X is the actual percent. So again, we have to write our absolute value, and remember, 58% happens to be our change, and then 3% is the margin of error. So we're going to write absolute X minus 58 less than or equal to 3, because 3% is the change. 3% is our change. Less than or equal to, because remember, it says it is a margin of error. It says use the inequality from part A to find our range of percent of Americans who solve and eat in the restaurant. So we're taking our problem, X minus 58 less than or equal to 3, and we're going to have our two equations. So we're going to have X minus 58 less than or equal to 3, and then the other one is going to be X minus 58 greater than or equal to negative 3. We are adding 58 to both sides. So we get X is less than or equal to, that is 61, and X is greater than or equal to 55. So for our solution set, it means that we are between 55 and 61. So we're going to say absolute value, or set builder X, where 55 is less than or equal to X, less than or equal to 61. And then we close our set.